Greetings and welcome to today's event on developing norms of behavior in near-Earth space. My name is Alyssa Gessler. I'm a master's student at the LBJ School of Public Affairs, as well as a Brumley Fellow specializing in space security and safety at the Strauss Center here at UT Austin. On behalf of the LBJ School, I want to thank our many wonderful co-sponsors for joining us today. Today, we're joined by the Strauss Center, the Texas Space Law and Policy Society, the Secure World Foundation, the Space Generation Advisory Council, and the European Space Policy Institute. We are thrilled to have you all on board for today's important conversation. It just so happens that today is the International Day of Human Spaceflight, commemorating the 60th anniversary of the first human reaching outer space. It seems only appropriate that a mere 60 years later, we are finally gathering for Dr. Jha to tell us once and for all how we ought to behave in space. On that note, it is my pleasure to introduce today's speaker, Dr. Mariba Jha. Dr. Jha is an associate professor of aerospace engineering and engineering mechanics at the University of Texas at Austin and program lead of the Strauss Center's Space Security and Safety program. He is also the Director for Computational Astronautical Sciences and Technologies at the Odin Institute for Computational Engineering and Sciences, also here at UT Austin. We welcome participants to enter questions into the Q&A box throughout Dr. Jha's presentation. My colleague Weston Weber, who is a first-year master's student studying global policy at the LBJ School, will moderate the Q&A session. Following the Q&A session, I will provide a brief overview of resources from our co-sponsors for students. And with that, I welcome Dr. Jha to take it away.
All right, Alyssa, thank you so much. Weston, great to be here with you. Thank you to the Strauss Center. Thank you for all the co-sponsors. This is going to be hopefully a pretty good event, and you'll get to hear some interesting opportunities at the tail end of this. So as with all Zoom kind of meetings, I'm going to go ahead and try to share your screen, kick this off with a very interesting send off here. Let's see if this kind of works. We'll go with that. Yeah, so here we go. We have a space environment with quite a few anthropogenic or human-made objects in the environment. I think we currently acknowledge, over 90 spacefaring nations at the United Nations. And interestingly enough, this kind of knowledge graph database called AstroGraph is just showing, first of all, the dots are not to scale. So that's one of the major criticisms that I get with this thing. But, all the people that want to challenge me with dot size, I ask them to step up and find a better way to show it. And it's been crickets, so I'm going to move on with that. But the dots pretty much represent where things are located, more or less, roughly, okay? Because there's a lot of ambiguity. And I think one of the things that I want to kind of highlight here is we're looking at, low Earth orbit, and you can see that there's kind of these trains, the string of pearls, these orange string of pearls that you can see kind of going around the Earth. And I'm going to just rotate here. You can see, there's another kind of string of pearls there. You can see that there's an orbital plane here, more strings of pearls kind of here towards the bottom. Here's another one. So the string of pearls, not to single anybody out, but those are all Starlinks. And so they're getting launched every few weeks. Currently, out of the population of anthropogenic space objects that we track, which is over 26,000 objects ranging in size from cell phone to space station, only about 3,300 or so are actively controlled. Everything else is dead or garbage or not serving a purpose. And out of the 3,300, about a third of that belong to the Starlinks, to SpaceX. And this is going to increase in time. And I want to say up front, the number of objects in and of itself, that's not the issue. There's a lot of space still. This again, the dots aren't to size. So representing the things as their actual size, you wouldn't be able to see a lot of it, any of it at this scale, actually. So it's just location is what this is representing. But it does give you an idea of number of things and kind of roughly where they're at with respect to the Earth. And then you have this kind of, geostationary, geosynchronous kind of region out there. You have this interesting string of pearls in pink here, which is presumably, what I call a super spreader event, a derelict rocket body that blew up in this geotransfer orbit. And basically, the apogee, the furthest point away from Earth, is not crossing the geobelt, but eventually, as Newtonian mechanics would tell us, as even Einstein's theory of relativity and whatnot, space-time, this is going to precess, and eventually this furthest tip will cross with this orbital highway that we lovingly call geostationary geosynchronous, where we have communication satellites. So this will become a highway that then on-ramps onto geo, and there's going to be things crisscrossing at significant speeds. Let's put it that way. So that's a current state of where are things roughly located. To get an idea of crisscrossing traffic, here we are just showing, looking at about 19,800 objects or so. We're asking ourselves the following question. Based on what we know about these things, if we could predict which pair of these objects is going to crisscross each other in the next 20 minutes, from now to the next 20 minutes, show me which ones are going to crisscross each other within 10 kilometers or 6 miles, okay? 10K, about 6 miles. And so this is just showing you low Earth orbit. I haven't included the geo type stuff here. This is showing you a histogram in terms of altitude. I can tell you that, 3 years ago, this was fairly flat over here, but now we see that it's becoming more and more populated, with the Starlinks and whatnot. We see relative speeds between things spiking at like 15 kilometers per second, or like 15 times the speed of a bullet. This one on the low end, these are things with very low relative velocity. And so these are the flatliners. Basically, the one here on the bottom is something mated to the space station, so that makes sense. This one right here, let's see, if you click on these things, you can get kind of an idea for, this looks like it's some Yalgan 32A. So it looks like that with Yalgan 32B, it looks like these things are fairly close to each other and maintaining some kind of relative speed, very low relative speed. So the things that are flatliners are things that have very low relative speed to each other. The things that are kind of spikes are things that are crisscrossing each other at very high speeds. The green dots are pairs of objects where both are actively controlled. The yellow dots are when one is controlled and the other one isn't. And the red dots are basically, they're both dead. So the strategy there is just, you hope that nothing actually bumps into each other. We saw recently in the news, just in the past week, that there was this cringing moment that maybe these pieces of debris might hit each other. And then we also saw something in the news about, one of the Starlinks and the OneWebs, and trying to, hopefully not play chicken in orbit and figure out who was going to move. And apparently, I think the OneWeb satellite ended up maneuvering. So these sorts of things are going to become a lot more frequent. These conjunctions or close approaches are not collisions. So I don't want you to think that they're equivalent. Again, the objects up there aren't like 1 kilometer in diameter. So these things are crisscrossing each other, but there's still, a fair amount of space between them. It's just kind of showing you what traffic patterns are looking like. And again, in the past 3 years, I've already seen this almost double in terms of amount of stuff crisscrossing each other within the next 20 minutes. So I wanted to just lay that out as an introduction to a conversation that we're going to have today. And what I want to do now is I want to reshare my screen, but I'm going to go with some slides. So I'm going to talk for a little bit and then open it up to leave a lot of time, hopefully, for some questions and answers. So hopefully, can everybody see that in PowerPoint mode? If somebody can just give me a yes, that'd be great.
Yep.
All right, cool. So look, I looked up we're going to talk about norms, I think, at some point. So I decided to Google this, as all good researchers do, Google it. And so this is what came up. I don't think this is what we want to talk about, this sort of use of the word, usual, typical, maybe not so much that. And a mathematical definition, this idea of the product of a complex number and its conjugate, I think I'm going to use that definition for today. Joking. All right. So what is it that we're trying to avoid, amongst other things when it comes to stuff in space? Well, we don't want any sort of harmful interference. And I'm just going to say, my kind of interpretation of that, right, is we want to prevent the loss, disruption, or degradation of space services, activities, or capabilities. We want to be able to do whatever we want peacefully, in the space environment, and do so unhindered and without interfering on others and without others interfering on us. So one of the things that I want you to keep in the back of your mind throughout, this talk is, if you want to know something, you have to measure it. And if you want to understand something, you have to predict it. Prediction will tell you whether or not you're understanding something or not. Okay. So we have a few concerns. Very recently, with spacewatch.global, I hosted a space cafe, Morbus Vox Populi, on April 8th. And I had some great guests, Kayuve Schrogel, Jinwan Yoon from China. I had Laura Grego, Dr. Laura Grego from Union of Concerned Scientists, and Artem Moknaktin from Kalish Institute of Applied Math. We talked about this a bit. And so these were some of the things that actually came up in that discussion, right? Will space become all about securitization? Meaning, is my null hypothesis that everything is a threat? Is that going to be my going in thing? Whenever there's something that I don't, I'm not able to. So this is back to the prediction stuff. Okay. So if something happens that causes me to be surprised, and we're going to talk about surprisal analysis. So if I predict something and when I get evidence, it doesn't really match my prediction. So that's already telling me I'm not understanding something. Is my going into this, is my null hypothesis, everything is a threat? Because if my null hypothesis is everything is a threat, that means that whatever action my default action is, or what the sequence of actions are, those by and large are not desirable for us as a space community. If the going in thing is assume that everything is a threat, the behaviors that ensue as a consequence of that null hypothesis are not great. And then the question is, okay, if that's my default, if that's my null hypothesis, usually we take the default action in three scenarios. If we don't have any more data, if we have too few data, or if we have overwhelming evidence that the null hypothesis is true, okay? So if we have no data, we're assuming everything is kind of a threat. That's not so good. If we have too few data, if we're ignorant, we're going to assume everything is a threat. That's pretty, bad news as well. All right, if we have overwhelming evidence that something is, okay, I think we've got something. But I really like one of the statements that supposedly Carl Sagan made, which was, absence of evidence is not evidence of absence. And so what I want to get to is, we tend to fall into a lot of confirmation bias, and we need to be very careful with that, because with confirmation bias, that can also lead to undesirable outcomes. All right. Another thing that was brought up, we have a technological arms race. Okay. Technology is improving, miniaturization, all these sorts of things. So there's this concern about weapons in space, right? We have this whole PPWT thing that apparently China and Russia wanted to advance, and others, kind of weren't so much for that because of this idea of dual use technology. And what I mean by that is that, one person's grappling hook for on-orbit servicing can be used as someone else's grappling hook to basically destroy a satellite or cause harmful interference. And the difference between the two is intent, okay? Intent of use. So it's not about necessarily the technology itself, it's about how it's intended to be used. And we'll talk about that here in a little bit. Peace versus deterrence. So, I was saying, everybody wants peace in space. No, silly Morbaja, not everybody necessarily wants peace, but I would say, by and large, people don't want conflict. Okay, so maybe they're not the same thing. They're trying to approach a common outcome, but how do we how do we deter in a peaceful way? Can we achieve deterrence of this sort of behavior, undesirable behavior, non-peaceful behavior in the space environment? We have a lot of ambiguity. Many opposing hypotheses can explain the same evidence. I'll talk about that here in a little bit. And, someone, brought up this idea of, space surveillance. If people start getting kind of upset or worried when they see satellites coming too close, whatever that means. I think we generally came up with this notion that maybe too close was anywhere between 5 and 10 kilometers away. So, when something comes within that distance, is the null hypothesis it's a threat? And I'm hoping that the answer is no. But, if we can agree to some common behaviors, protocols in how we operate stuff in space, hopefully that can start allaying this idea of intent. So here I say et unum pluribus, right? So out of one many versus the opposite stuff on as part of the United States kind of motto. So look, it's one common environment, many competing needs. From the safety perspective, most people are worried about collisions and these sorts of things. From a security perspective, we want unhindered use and access, but we want to be able to avoid threats to our system, services, and capabilities. And it's not just government against government, it's also companies against other companies. And there's never been any domain of human activity absent malicious behavior. So that's never existed. So to think that space doesn't have that is naive. Of course that exists in space, and it's going to just increase. So the question is, how do we become aware of it? How do we dissuade or deter that sort of thing? And then from the sustainability perspective, what is the anthropogenic or human derived impact to the environment itself? We've talked about things like orbital carrying capacity, colleagues, at ESOC, at the European Space Agency, some of us here in the United States looking at this as well. Space traffic footprint, carbon footprint analog to kind of understand the burden of these things in space. And, under the World Economic Forum, some folks, ESA, MIT, Bryce Technologies, and yours truly at UT Austin have been developing this space sustainability rating, and hopefully it's moving to a phase 2 here pretty soon. This idea of the space traffic footprint, right? It's like, okay, what is the burden upon safety, security, and sustainability that any object, dead or alive, poses on anything else? Okay, can we quantify that as some composite index and basically assign these things to all these objects to really understand the environmental impact of debris and all these things? All right, so I had to, it's Throwback Monday, not Throwback Thursday. So this is me. I think I was like 19 years old here as a security policeman in the U.S. Air Force, guarding nukes at Malmstrom Air Force Base in Montana. This is where I learned what a threat was. Okay, I was told, and I was trained to understand that a threat required the concurrent existence of these three things. Opportunity. So for space, that's mostly about the physics and predicting relative motion and location of things. So what's the opportunity for something to cause harm, harmful interference? Capability. So beyond just skin tracking, dots in the sky, no kidding, what are the physical, operational, and functional characteristics of things? What are they capable of doing? So there's a need to kind of understand that if we want to allay the kind of threat thing. But those two things, opportunity and capability, don't necessarily have to be a threat. The additional piece that has to exist is this idea of intent. And there are no sensors that directly measure that. And if you know of some, then you're going to be a very rich person. So intent has to be inferred. And when we say inferred, because it can't be measured directly, that means that we're going to draw conclusions from a set of data. Okay, inference is drawing conclusions from a set of data with an associated uncertainty, because you can't know it exactly because you didn't measure the whole thing. So inference is a very interesting thing that we're going to talk about here in a little bit. So the difference between a hazard and a threat is that a hazard has the opportunity and capability for harmful interference, and the threat has the additional ingredient of intent. And so how do we measure that? How do we infer it? And how can we disambiguate? That's a big deal. So some practices that I feel are highly recommended certainly by me, but I think you can find this in other domains, is that we need the development and maintenance of this multi-sourced information, some digital library, digital twin, shared registries and databases where we can cross-reference all these things between Union of Concerned Scientists, Space Command, Russian JSC Vimpel, anybody else's databases or registries, UN USA, DISCOS. So can we have a way where we can cross-reference and share some of these pieces of information about stuff in space? Can we monitor, verify, assess anthropogenic space object behaviors, events, and activities, and make that very public facing? Okay, make it very transparent. Coordination and planning processes. We kind of saw, how that played out favorably this time between OneWeb and Starlink, presumably, right, with trying to maneuver to get out of the way. But can we develop protocols, common practices that can maximize predictability? Okay, if you can maximize predictability, you can minimize misinterpretation. Another thing I'm going to talk about is the idea of capacity building. I'm going to talk about this soon, but this is just to say that there's a very uneven body of knowledge about how things in space behave and space operations. So if there's uneven knowledge, then the practice is surely also going to be uneven. And then the idea of enforcement of compliance. Will some international organization start taking people to jail over stuff? Maybe that's like bridge too far for now. Maybe it's over the horizon. We can't see it, right? It's not in our line of sight, but certainly each nation state that has responsibilities under Outer Space Treaty and stuff like that can have its own national space laws and enforce these things for its own constituents and show the rest of the globe that it's doing that, because that would actually build confidence, okay? So, all right, so we have this assumed space object population. I told you folks about 26,000 objects that we track, ranging in size from cell phone to the space station. Some of this stuff, the charts come from NASA's Orbital Debris Program Office at Johnson Space Center in Houston, led by none other than the chief scientist, Dr. J.C. Liu. And I say assumed because, look, if we try to understand, I guess, hypothesize the number of objects that could actually cause harm, those go all the way down to, fleck of paint, millimeter in diameter, and those are not trackable. Okay, we can't track those things. So we have to somehow try to invoke inferential statistics to try to get some idea of what that population is. So basically, out of all the things that can cause harm, we track 1% of the things that could cause harm. And out of the 1% of things that can cause harm, only about 6% of those things work and everything else is garbage. So, 6% of 1%. That's pretty low. All right, so I showed you this. I don't want to belabor that. This is just saying, look, in the proximate future, and this is not everything, we have a variety of commercial players interacting in a common environment, sharing orbital real estate, orbital highways with each other. So we need to be very aware of that. So we have this thing called space domain awareness. And at the bottom floor, basically we have a space environment that is very dynamic, everything from gravity to solar flux, charged particles, the magnetic field, micrometeoroids. These things have effects and impacts on the anthropogenic space object population. Many of these effects and impacts are still unknown, so there's science that needs to be done to extend the body of knowledge for us to understand these things better. And the space environment also motivates how these things move and behave in these orbital highways. That is not completely known or characterized because gravity is an equal opportunity accelerator. It doesn't care about an object's size, shape, or material properties, just about location. So it's just space-time informing things, how to move within it. But there are non-gravitational accelerations experienced by these objects, and every single one of those is dependent on these physical properties, size, shape, material properties, and orientation. And guess what? We don't know about most of the stuff up there, the physical characteristics. That's why there has to be an exercise somehow in getting more information on the physical properties of these anthropogenic space objects so we can be better positioned to predict how these things are going to behave, to even inform how we want to regulate how things interact with each other. Okay. And then on the far right side, I told you it's not just about peaceful intentions. There are folks that maybe have some malicious intent. So we need to be aware that that exists. So what do we need to provide with space domain awareness? For sure, transparency. What's up there? Who does it belong to? What can it do? The what can it do is part of this capability thing, okay? Predictability. Not only is it astrodynamics, science that studies motion of stuff in space, but also given any common scenario, like the one between the Starlink and OneWeb, can we predict what the two actors are actually going to do? Is that a given? Can we just say, you know what? I feel safe because I know exactly what's going to happen. So if the answer is no, then that's an issue. Okay. And I can tell you, having personally interviewed different mega constellation folks in Leo, there's not a single, I can tell you, not a single one of them actually agree on the risk posture and the decision-making criteria for when to get out of the way. So they don't agree on that. That's not a common thing. That is an issue. Okay. The other thing too is even with legal instruments, Outer Space Treaty, Convention on Space Object Registry, liability and damage, so on and so forth, is there a common interpretation of these things? No, because a lot of that goes through cultural lenses. We have to become culturally competent to understand, measure, how are people interpreting these things and how they interpret it and then how they implement it. And is that implementation leading to desired outcomes? All right, space domain awareness, trying to understand this in terms of risks and impacts. So this is a way that I like to understand it with this sort of Johari window, which is the ideal decision-making occurs when we have known knowns. So I've said before this whole, Donald Rumsfeld thing, years ago, the known knowns, known unknowns, unknown unknowns. There's some rhyme and reason to that. And so out of the two words, what I want you to think is this. The first word relates to the things that you are aware of, and the last word relates to what you have measured, okay? So the first word is awareness, the last word is measured. And I'm back to, if you want to know something, you have to measure it. So known knowns are things that you are aware that you have measured. Okay, great. That's the best place for me to make decisions. I've quantified my uncertainty, all that stuff, right? But there are things that we are aware of that we have not measured. Like, for instance, with the physical characteristics of all these objects in space, we are aware of not having measured most of that stuff. So we have to now assign uncertainty to that so that in our risk posture, we can take into account that we are aware of things that we have not measured. They're not known. I think the bottom two are very interesting because the unknown unknowns are enigmas. Basically, it's like we're unaware of it and we haven't measured it, so they can't be known by definition. And so what we hope to do is we'd like to be able to create a big data problem for ourselves, massively aggregating disparate sources of information, heterogeneous data. And in that aggregation, can we pose interesting questions of that aggregated data set that can then lead to things that we are unaware of having measured? If it was measured, it can be knowable. So hopefully from data mining, we can discover things that we have unknowingly or we're unaware of having measured, and then migrate the unknown knowns to the known knowns for ideal decision making. All right, descriptive versus inferential statistics. We can't measure the entire domain, so the entire domain is not exactly knowable. All we can do at best is infer. So we can measure samples of the population. We draw conclusions about the entire population from the measured samples and hope that it's representative enough, okay? So one of the things that Rudolf Emil Kalman, co-inventor of the Kalman filter, said is uncertain data cannot provide exact models unless we apply prejudice to remove the inherent uncertainty. That is a big deal. A lot of people like to do that. They like to apply prejudice so that they can just get to, the best answer, best athlete, best of breed. Anybody who uses these sorts of superlatives that says that they have the one ring to rule them all, the best answer, the unique, run the other direction because they're probably quite clueless. Okay, quite clueless. So one of the things that I brought up earlier is this idea of uneven knowledge. Even across the NATO alliance members, okay, I've given lecture series for NATO related to space domain awareness. I can tell you just across the NATO alliance members, there is significant disparity in the technical knowledge about how stuff behaves in space and, you know, space operations and that sort of stuff. So if the knowledge itself is uneven, the implementation of the knowledge is certainly going to be uneven when you look at the entire domain. So the practice is also uneven. What we'd love to do, right, is through capacity building, help provide more evening of that knowledge base so that the individualized knowledge can be more common knowledge. And if we can achieve more common knowledge, then we can achieve common practice. We can, not that we will, but it helps. And so the norms of behavior, the development of these protocols are the harmonizing element to bridge us from the knowledge to the practice base, okay? Every operator has their own OODA loop. They have their own sets of observations. They do whatever it is that they do to this in their ways. There's some standards out there, but others, you know, just kind of develop their own thing, and they come up with their own decisions and actions. So as long as we have individual practice and implementation, we have individual OODA loops. This is not favorable for long-term sustainability, safety, and security. What we'd like to be able to do is harmonize some of these decisions and actions, right? So we want to make the OODA loop something where maybe there's some standardization to some extent. Remember how I said multiple hypotheses that could be opposing can explain the same evidence? This is part of the ambiguity that exists. So when a satellite experiences an anomaly, a question could be, well, was it as a consequence of something that Mother Nature did, or did Jimmy schwack my satellite when I wasn't looking? Oftentimes, both of those hypotheses explain that evidence. So we need to find a progressive amount type of evidence that can help basically whittle that all away. We detect lots of things. We don't track everything. So detections is just that. This is a set of detections over a single night. But the black dots are things that were detected, and we believe that we know the first and last name or the identity of the object. Everything else is unknown. So this is real data, and this is not a great scenario because it says that there's a lot that we can't assign a first and last name to. Because it turns out of most of the objects on orbit, very few of them report their identity, okay? So we have an identity crisis. If we have multiple sources of information, mostly on objects that are not saying, hey, I'm object 1, 2, 3, how do you sort that out? How do you combine heterogeneous data in such a way with different notions, different things being applied to it to sort that identity crisis? We have to figure that out, okay? What we'd love to do, back to the measure to know, is start from the left. What combinations of things that we can measure lead us to infer physical characteristics of these objects, and which combination of those lead us to understanding or knowing functional or inferring functional, operational, so on and so forth, to move to the right towards classification. It's not just people, in space affected, it's people on the ground. This is just something that we put together to show what kind of some of the light pollution is. This is all human-made objects reflecting sunlight towards ground-based observers that impact astronomy. And this is a single night burst, the catalog right now. The streaks are the objects reflecting sunlight, and visual magnitude, humans can see down to about 6 dimness, larger numbers are dimmer. And this is now going through the middle of the night. So it's not that the objects aren't there, they're just going through the Earth's shadow, they're being eclipsed. And then towards dawn, you can see the swarm grow again. So this is what astronomers have to deal with every night. And the answer is not getting better because we're not going to stop launching satellites, right? So as much as you can want to work to make things less reflective, which SpaceX for sure has worked well with the astronomy community to try to minimize that impact. I'm personally aware of that. We still have issues. Back to confirmation bias, and I'll wrap things up here hopefully pretty soon, is we need to try to avoid that as much as possible. I'm going to spare you some of the technical mumbo jumbo unless it comes in this could be a separate talk on how to avoid this confirmation bias by appropriately using Occam's razor, maximum entropy, falsifiability principle, surprisal analysis, and strive to gather complete data. And what I mean by data completeness as a dimension of data quality is, can we come up with enough data where out of our ensemble of possibilities, we use the data with Karl Popper's falsifiability principle is only remove hypotheses that can be shown to be impossible. So as long as it's possible, it's still in your bag of hypotheses that explain the data. Only remove hypotheses shown to be falsified or impossible. And can we gather enough evidence to remove all but one hypothesis? And if we can gather enough evidence to remove all but one hypothesis, we can claim uniqueness and that our data are complete. If you don't have a data set that rules out everything except a single hypothesis, your data are not complete. And I say that by and large, we do not have complete data when it comes to understanding stuff in space. And here's another reason, right? Because different data have different dimensions in understanding things. And this is why we need to combine all the data sets to, again, whittle out hypotheses that are impossible. So I'm just going to difference between, different catalogs and what's up there, and even common object. One object has multiple opinions. What are the disparities, inconsistencies, consistencies? We need to monitor, do a better job of jointly monitoring the space object population. And one of the things that we looked at, I told you about understanding how people interpret stuff. We looked at the UN object registration database. We scraped all that stuff in an astrograph. We came up with our own kind of rating system: 5 stars within 120 days, 4 stars within a year, submitting the registration stuff, 3 stars within the second year, 2 and 1. And that was the weighting. It was interesting to see, countries that have registered more objects are more favored. So basically, it doesn't show you the people that took like a decade to register something. So there's that. But it kind of shows you that this is not it's not a uniform distribution across the board. So there's different interpretations of what as soon as it's practicable actually means. And the first step to harmonizing and developing protocols in some sense is understanding how people are interpreting things. So I'll leave you with that. Whenever a model is built, it's always proper to ponder the basic scientific question: is the model really based on the data, or is an artifact displaying the prejudices of its creator? We should strive to be as prejudice-free as possible, which means whenever we evaluate this problem of stuff in space, we actually need to be very honest enumerating all the hypotheses that explain the evidence, because that properly models our ignorance. And we will be in a position to have a better answer in as much as we embrace the actual ignorance that we have about it. Thank you very much.
Thank you, Dr. Jaw, for that really interesting talk. If it's okay with you, I'll just start throwing out some questions so we could try to answer as many as we can. And just a reminder, my name is Weston Weber, and I'm a master's student at LBJ. And so our first question comes from Mark, who is curious on how I guess these treaties or agreements are made for things in space. And then just to add on to that, I guess how likely is it that these treaties will get passed, and then what are some of the challenges that we are seeing today to these agreements?
Yeah, so I'll put it this way, right? I mean, the work that goes into actually having a treaty that is, ratified and accepted and all these things is Herculean. Some people are pushing for, more laws and this sort of thing. I am not a space lawyer, even though I am a proud member of the International Institute of Space Law. But I will say, as a non-lawyer, that I believe that we need to do a better job of understanding, of quantifying how are people interpreting the current treaties, and basically share that that understanding of how these things are being interpreted and implemented, and then ask ourselves a question: is the interpretation and implementation leading to improved space safety, security, and sustainability? If the answer is no, then we need to have a conversation about how these things are interpreted and see, can we come up with a better or agreed upon method of interpretation so that the implementation leads to the desired outcomes.
Thank you. And then our next question, I'll just read verbatim because they worded it really good. So they said, you said earlier that one person's on-orbit servicer is another person's weapon, but following your model, something that distinguishes OOS service providers from weapons is the cellular communication of that intent. Is a commercial contract for a service not a pretty direct public signal of intent? And then what can commercial providers of OOS do to otherwise signal peaceful intent?
Yeah, so I think just because it's a commercial entity, doesn't mean, and I think clear communication of the intent. I think that adds to it. I don't think that necessarily says, oh, thank you for saying that. Now I don't have to worry about you ever again. So that doesn't make sense. But certainly, I think that communicating things, trying to come up with ways to be transparent and saying, this is what my thing has, these are the capabilities that the object has, this is where it's located, this is where it's going to be. These sorts of things help signal intent for sure.
And then on the same thread of intent, there was another question from Kevin, who asks if there has been any discussion in the international community regarding, I guess, measuring intent using inference, like using previous behaviors when states disregard or ignore existing internationally accepted rules or law.
Yeah, so look, I mean, I think that there is validity in looking at culturally how countries see themselves as citizens of the world, how they view others based on evidence on how they've treated others historically and these sorts of things. And kind of the trend, what are the geopolitical trade winds of these countries, because that manifests in how they what their intent might be and how they use space services, activities, and capabilities. So I think that sort of a priori knowledge is good to bring to the table, not as a uniquely defining kind of thing, but it adds evidence. And I think it provides context to help understand and quantify how people are behaving to address this idea of the inference, drawing conclusions about intent when it's not directly measurable.
And then Victoria asks if there is a right way for space objects that may be on a path for potential conjunction. So like two active satellites that could, in theory, be controlled by their OO.
Yeah, so I think that it would not be difficult to come up with, let's call them rules of thumb to talk about this right of way. And here's the thing, right? I'll put it this way. Here's why I know this is possible. Not that long ago, I had one of my morbus vox populi was about the role of theology in space exploration and space sustainability. And I came to learn that I guess some folks, I believe in Indonesia, came up with rules of thumb for Muslims on how would Muslims engage in daily prayer on Mars? Okay, because clearly the Mecca is not on Mars. If a religion can come up with these rules of thumb for how to engage on another celestial body, we can absolutely come up with a rule of thumb of right of way between any owner operators that are sharing a common orbital highway. So I believe, yes, there are probably several ways to define this right of way for space objects. By and large, it means that space operators just need to be in the same room and they need to agree on some things and just be very candid about their feelings. Look, I've come to understand that being able to openly share what it is that you feel sooner rather than later can lead to very positive outcomes. And so I think if everybody can sit in a space of slight discomfort and just be candid, but be professional about it, I am extremely confident that owner operators could come up with this sort of right of way, rule of thumb kind of thing.
And then our second to last question is coming from Nathan. And they ask, are there any analogs we can use to form a standard framework for decision-making in space, or does space require a novel framework?
Well, I think that there are analogs. I am a big believer in what's called data-driven decision-making. I subscribe by and large to decision intelligence as conceptualized by Google, specifically Kazi Kozyrkov, who's like the chief decision intelligence officer at Google. Love her videos, very easy to understand, and she can take complex things and make it easy to digest. So yeah, I think we can find analogs in other domains and not necessarily copy and paste for space, because I think that's silly, but certainly consider them as points of departure and just see where these things are useful and where they're not so much, and make the adjustments as we need.
And then I'll be combining two questions because they're on the same idea of a satellite operators. Do you think operators have a duty to prevent collisions by using services for providing data and comprehension of the LEO environment?
Yeah. So here's the thing. When I see Article 6 of the Outer Space Treaty, I read, nation states have the responsibility to provide authorization and continuing supervision of the activities of non-state actors. To me, continuing supervision means that governments alone, with whatever sensors that they have, that is insufficient to be able to be aware of all the activities that these folks are doing. And so I think that, to some extent, to answer your question, I believe that part of the authorization should make it a requirement for these companies to provide the government with all this extra information that could help them actually close on, at least my interpretation of continuing supervision of their space activities, and be able to use such information to help disambiguate and avoid collisions and all these other things. So absolutely, I think that should be, nation states should, all of them should require the folks that they're authorizing to provide those sorts of details to them, so that they can actually meet their responsibilities regarding these treaties.
Okay. I think that's all the time we have for questions. Thank you so much, and I'll pass it to Alyssa.
Wonderful. Thank you so much, Weston, for moderating that. I am going to take the opportunity. We have just 2 more minutes, and we've seen a couple questions in the feed relating to theology and ethics in space operations. Could you speak to the 2 of those briefly to wrap up today's event?
Yeah, so look, certainly for the theological aspects, we all, were born and raised in very specific parts of the planet and of humanity, and have cultural tendencies. And to think that our beliefs, what our relationship is to life, like that, in no way, shape, or form is a contributor to our behavior as we evolve in space, I think is naive at best. And I think that there should be an explicit mechanism to be in, part of inclusivity is, to me, inclusivity is giving diversity a voice. And I believe that, theologians and religious leaders should have a seat at the table, at the UN and other organizations regarding space, so that they can weigh in with their interpretations and their perspectives on this. And I believe that we'll all be the better for it.
Wonderful. Well, thank you so much, Dr. John, and thank you again, Weston, for facilitating that. Before we close out today, I'm going to provide a brief overview of resources available to students and professionals from the different entities here at UT, as well as from all of our co-sponsors. These resources will be linked to on the Strauss Center's event page for today's event, so that you can explore them further after we wrapped up here today. First and foremost, at the Strauss Center, we're producing an informational space policy video series. It has episodes that break down basic space concepts, as well as interviews with experts in the field. We also recently launched an op-ed collaboration with Spacewatch Global, wherein UT graduate students can have their op-eds on space policy and law duly published by both Spacewatch and by the Strauss Center. We also host our annual Space Traffic Management Conference annually here in Texas, hopefully in person this year, in January or February. We welcome folks to submit paper proposals and to attend and listen to a diverse array of talks on great space policy and technical fields related to space issues. Finally, the Strauss Center sponsors different space law and policy courses each year. We will link to those as well on the page that will live on the Strauss Center's website. The Secure World Foundation recently published the second edition of their Handbook for New Actors in Space, which provides a broad overview of the fundamental principles, laws, norms, and best practices for peaceful, safe, and responsible activities in space. Registration is also now open for their annual Space Sustainability Summit to be held online from June 22nd to 24th. The summit is free to attend for students, so do be sure to register soon. The European Space Policy Institute publishes an array of useful resources on their website, including in-depth reports on specific topics and issues, a monthly news digest on trends in the global space sector, and short thematic briefs on selected space issues. They also just launched a new call for papers on the topic of spaceports in Europe and would welcome any students or professionals to submit abstracts. The Space Generation Advisory Council's Space Law and Policy Group serves as a forum for young students and professionals to discuss emerging topics in space law and policy. And they also conduct several collaborative ongoing projects, which I highly encourage any interested students to participate in. These projects are an excellent means of expanding your space expertise and also networking in the community. Finally, the Texas Space Law and Policy Society is a student group here at UT Austin, which is that centralizes resources for students, and their officer elections are coming up soon for any UT students interested in taking on a leadership role. Again, the resources I mentioned here will be accessible via the event page on the Strauss Center's website. Thank you all for attending, and thank you again to our co-sponsors for supporting us today. We hope to see you again soon.
Booyah, booyah.
I couldn't have said it better myself.